MotionBuilder provides you with a sophisticated set of tools for doing real-time character animation. In this presentation, we're going to be looking at how we can use MotionBuilder to set up shaders, retarget animation data onto existing characters, use the story tool to edit together multiple animation clips. Then we'll be looking at animation layers, and finally we'll finish off using the ragdoll solver to dynamically generate some character animation. The first thing that we're going to do is add some visual complexity to this ground plane. If we look at the material, you'll see that we've already texture mapped onto this ground plane a diffuse channel, and I want to add some breakup to that diffuse channel by texture mapping a normal map. So we'll go ahead and we'll enable the advanced mode, go down to the bottom of my textures, and just simply drag and drop out a new normal map file that I made inside of Maya. We'll assign that to the normal material. You can see that it's now been texture mapped into the normal map slot, and nothing really changed in my viewport. And that's because this exists in the advanced mode. And what the advanced mode needs is it needs another shading element added onto the material to represent that. So things like transparency, reflection, bump maps, they all need other little shading elements basically just put onto that material through the append operation to layer the effect on top of the default material. In this case, we're going to go ahead and enable bump lighting. We'll turn the directional light to be the only light that's affecting that normal map, and we can go ahead and just drop down the intensity of that, maybe drop down the specularity a good bit. And if we kind of scroll over to the top of this character's feet here, you can see that we now have this normal map basically tiled several times across this overall diffuse texture, and it just kind of breaks up the effect of that ground plane slightly. Let's go ahead and change that normal map's texturing type to be a MIP map, so it kind of blurs that out on the edge a little bit there. So the next thing that we want to do is go ahead and start to change the diffuse channel. You'll notice that on my buildings I've gone ahead and inside of Maya I've done a bunch of texture baking work or light baking work, and we don't really have that represented in the ground plane. Now I've actually baked out another texture map in Maya already to represent the lighting information, and what we want to do is we want to start to modify the diffuse channel so that it can take into account this lighting information. We want to multiply it together with the original diffuse material that we see here. So to do this inside of MotionBuilder, all we have to do is add on a layered texture. So we'll apply this to the diffuse channel. If we go to this layered texture and bring up the options for it, we can start adding in multiple textures in the layer editor. So again, we want to just go ahead and drag and drop this diffuse onto the first channel. We'll go ahead and then add onto that the light map into the next slot down. We'll switch the blend mode over to modulate, so we're going to multiply those together. And now you can see that we basically have gone ahead and generated a much more refined look to this ground plane by adding in just that simple normal map and multiplying in that shadow map to kind of ground the objects onto that and get those shadows lining up with the building shadows. So now that we've done that, let's go ahead and turn off the ability to select the ground and begin looking at how we can do some retargeting operations inside of MotionBuilder. So to begin retargeting information inside of MotionBuilder, we need to teach it about the hierarchy of the skeleton that came in through the FBX file format for Maya, Max, or Softimage. So what we get when we open an FBX file up is obviously the geometry, the texture information, the bones, and some skinning information. And what we need to do is teach MotionBuilder about the hierarchy of the skeleton. So to do that, we need to drag and drop a character node onto one of these bones. The character node will go through and ask us whether or not we want it to be a biped or a quadruped. Obviously for this character we want it to be a biped, and we're doing this in the T stance down the z-axis, and essentially we do this for every character that comes into MotionBuilder, and we're zeroing out the local rotations. The characterization process automatically will look to the names of the joints and try to find matches for the mapping list. If the names are correct, it'll fill these in. There's 12 base joints that need to be required for MotionBuilder to begin working with the character. They're pretty simple things like where's the hip, where's the end of the arm, where's the head. If you have extra joints inside of there, MotionBuilder will use that in the control rig and in the retargeting. They're just not necessary. So you get the 12 base joints filled in, you have everything you need to begin working with the character. This is the same process for every character that comes into MotionBuilder, and this is what gives us the ability to seamlessly transfer information from one character to another character. So with that populated mapping list, we can go ahead and create the control rig. In this case, we're going to make an FKIK solution. and we can go ahead and turn that control rig on. I'm going to change the look and feel of that control rig slightly so that it's a solid look, and we no longer need to see those default joints. So with this set up, I now have everything I need to begin working with this character and begin animating it. I can grab one of the IK handles, one of the little markers here, and just simply begin positioning that around. So this is using inverse kinematics. This actually has the ability to also work with forward kinematics. Obviously, if I grab a joint and begin rotating it, I'm going to be using the FK to solve that. And the thing that's kind of cool about MotionBuilder is it's all built on top of the Human IK solver. And what the Human IK solver does is it gives us the ability to solve beyond just the body part. So if I grab this hand and I begin to overextend it past the range of that body part, you can see that MotionBuilder has the ability to transfer that energy all the way through the hierarchy of the whole body. Now this is really great when it comes to just doing simple keyframe animation and posing of characters, but it's also very key to the way the retargeter has the ability to deal with difference in size proportion of characters. So now that we've got our character's control rig set up and our little guy defined in our environment through that characterization process, let's go ahead and look at how we can begin retargeting some information onto this guy from some motion capture. So in my scene I've already got another character, and it's a soldier character. We kind of look at the animation that's on this guy. You can see that we have kind of doing some back handsprings here, and you'll notice that these characters actually are quite dissimilar. We'll get this guy back to the stance pose here. They're quite dissimilar in their size. So this guy has kind of human proportions. My little man has very short, stubby little arms. And the retargeter actually has the flexibility to deal with these differences in sizes in a very elegant and seamless way. So up until this point, we've been moving this character around using the control rig. So basically the control rig has been dragging around this skinned joints. We're going to switch the input of this character to be, instead of the control rig, the actual soldier. So just by doing that, we've automatically set up a retarget. Regardless of size of the character, the retargeter has the ability to deal with this. By default, what it's trying to do is it's trying to match up joint angles. So you'll see that even though these characters are very dissimilar in their size, the joints are actually lining up perfectly. So we're telling it by default to be more biased toward the FK, which works really well for things like the legs. MotionBuilder is automatically going to make sure that those feet ground. The translation is being compensated for that guy's shorter gait, but you'll notice that we have some problems with the hands. Obviously, this guy has these very short little stubby arms, and if we're matching joint angles, they're never going to be able to go down there and reach the ground. So what we want to do is we want to tell for the hands that we're not as concerned about matching joint angle. I'm more worried about matching the overall effect or in the whirl position of this marker. So we're going to tell it to reach the IK handle both in translation and to reach it in orientation. So if I just turn the T and the R up, you can see that it basically pulls that guy down. The pull value allows me to adjust whether or not it's going to be transferring energy through the whole hierarchy. So if I zero this out, it's sort of like using a body part mode, so it's only going to stop at the shoulder joint. If I start to increase the pull, you can see it has the ability to actually stretch. Look at his little leg right here. It has the ability to use that HIK algorithm or that human IK algorithm to transfer that energy and solve it through the whole hierarchy of that skeleton. So again, we'll turn the hand up, kind of crank that guy on. Just for fun, we'll go into our character settings for this guy, and we'll also turn on floor contacts for both the hands, and you can see that they pop up a little bit there, and the feet. So everything happens in real time, right? I'm doing this retargeting, I'm modifying it, I'm layering on top of that HIK algorithm to make sure those hands come down and meet, and it basically just comes in and works and it looks great. And again, regardless of scale or size, MotionBuilder can handle all of that for us. Alright, so let's go ahead and jump over to the next tool that we want to look at, which is the story tool. Now that I'm happy with that retarget, I'm going to go ahead and plot that information back onto my character's control rig. We don't need to see the display of that skeleton of that soldier anymore, so let's go ahead and hide that up and we'll jump into the story window. Inside of Story, which is MotionBuilder's Nonlinear Editor, we have the ability to generate character tracks or camera tracks. They can both have time discontinuities in them. In this example, we're just going to do a simple character track. We'll tell it that it's the new character that we made that we want to insert into this. And I'm going to go ahead and grab the animation that's on our current take and put that into our time slider. So what this does is it now gives me a clip of that animation in a nonlinear editing environment. I can obviously drag and drop the position of that clip around in my timeline. And we can use this nonlinear editor to actually start to string together multiple animation clips. So let's go ahead and just pull this back a little bit here. Jump over to my folder, and we're going to drag and drop in a new animation onto this character. So it's just a simple process of dragging and dropping that clip in there, and you can see that we now have our character being driven by multiple animation clips. In this example, we have the run, kind of comes up, turns 90 degrees, then he goes back and does his back handspring here. And you'll notice that these clips start and stop in drastically different positions. So that's the first thing that we want to fix inside of Story. Let's go ahead and get this clip sort of dragged more toward the beginning of our time slider here. And I can specify at which point I want to have this match happen. So we're going to go ahead and grab this foot. I'm going to tell that foot to be my matching object for this clip. So we'll bring up the match options. Left angle is what we want to match around at the start of the selected clip. That sounds like a good option. We'll go ahead and we'll hit apply on that guy. We can turn on the ability to see our trajectories of our multiple clips here, and you can see that here comes my character. He basically does a run. This is the pose that those joints are going to try to match into at the end of this next clip, and you can see that there's a little bit of difference between those guys. That clip and that clip don't really exactly match up. So we're going to fix that by just simply doing a slight little cross dissolve between those two clips. It might be a little extreme right there. Zoom in on this guy a little bit. I only want that to fade over a few frames, so it kind of does this kind of nice little jump, little hop skip, and then he starts doing these back handsprings. Now, the other thing that's kind of cool about the Story tool is I can actually go in here and start to change the position of, in the orientation of these clips. So if I wanted his run to end in a slightly different position, I can just simply do something like that. We'll go back to this clip. On this character, we'll rerun that match around that same left ankle. Actually, let's go ahead and grab that guy's left ankle and rerun that match. Kind of get those clips lined back up to each other. So you can see the power and the flexibility of this, the ability to work in this in a nonlinear fashion, cross dissolve between multiple animation clips, change the position and the orientation of where those clips start, see their trajectories, is a very powerful set of tools when it comes to layering animation on top of each other or stringing multiple animation clips together. So now that we're done using Story to edit together these clips, let's go ahead and plot that information back into our current take and look at how we can use animation layers to go ahead and begin refining the effect of this animation a little bit more. So as we scrub through our time slider here, we get our two back handsprings, and then obviously we get to this back flip, and this is the area that we want to use animation layers to start to tweak the look and feel of this piece. The animation layers now work very similarly to the way they work inside of Maya. So let's go ahead and create a few animation layers. I want to have unique controls for the feet, so we'll rename this foot L, and we'll rename this one foot R. If I right mouse click on top of this layer, you can see we have the ability to change the layer mode from an additive mode to an override mode. We can also change how the accumulation works, either per channel or per layer. We can obviously mute, solo, and lock layers, so let's go ahead and rename this one flip. And the final thing that I need to do on the setup of these animation layers before we begin animating is just make a simple parent-child relationship. So I want the feet to actually be children of the parent of the flip layer. So we'll just drag those guys down. I have a little folder that I can use to compress or contract that parent-child relationship. And any layer that I have highlighted is going to be the layer that we're keying into. We also have the ability to change the order in which these layers evaluate. So I can push layers up or down to modify their evaluation order. So let's go ahead and grab our flip layer. Let's grab our character's waist, move forward here right to where he's about to take off. And let's just set a simple keyframe there. We're kind of setting a 0 key there, and we'll set a 0 key sort of where that guy lands on the ground. And right about here where he's in the middle of his jump, I just want to raise my character up. Notice that when I raise my character up, his feet are basically pinned, and that's because the T and the R have been turned on. At any time for any of these body parts, I can go in here and basically enable or disable the effect of pinning for any individual body part. And this really aids you in the posing of characters. It's a simple little thing, but it actually makes working with MotionBuilder extremely fast and efficient. So one more time, I'm going to go ahead and just raise this character up a good bit. maybe pull them out here slightly like this and hit the S key. Notice when I keyframe it, I get a stroke. So the stroke is giving me a visual cue inside of my viewport that at this frame, all of those bones have been keyframed. Obviously, if I scrub off of that frame, the stroking disappears. Again, when I get on top of that keyframe, I get that nice visual cue that there's been some keying information added to it. At any time, you can go in here and adjust the weighting for a layer. So you can animate the weighting. You can basically use this to dial on or off the overall effect of that animation layer. So to finish this off, let's go ahead and grab this other foot here that has that's still pinned down. And let's start to animate a little bit of keyframe information on this guy. So we'll put a tweak. Actually, let's do this as a body part. We don't need to do a full body key. Notice the highlight selection is a little bit different now. So that's giving me, again, a representation of what bones will get keyed when I hit my S key. So we just set a kind of 0 key there, set another 0 key there, move my character up, give him this really nice kick. Maybe change the orientation of that marker a little bit so that his foot's kind of kicking straight out. Hit the S key one more time. And again, for each layer I can go in here and start to adjust the overall effect. I can mute the foot layer, or I could mute the overall effect of the parent, and that's obviously going to zero out the foot and for both of those. So that's just a quick overview of how you can use animation layers to start to modify the existing animation of your character. So it's a very straightforward process and pretty elegant inside of MotionBuilder. The last feature that we're going to look at is how we can use the physics solver to dynamically animate a trip on top of the previously existing animation that we already set up. MotionBuilder has multiple physics engines that you can choose from, or you can use the API to add your own. In this example, we're going to be using the PhysX engine, which will be computed on the GPU. It's also worth mentioning that the skinning operations inside of MotionBuilder can now also be handled on the GPU, which further accelerates the performance of the application. So now that we've got our physics solver in our scene, let's go ahead and start to add some physical properties. So what we want to do is use a ragdoll to go ahead and animate the effect of this character falling after a certain frame. So we'll go ahead and we'll add our ragdoll solver onto our character. We'll go to our setup node and we'll create a ragdoll approximation, which is essentially a collision object. You can use the move, scale, and rotate tools to adjust the overall size of the collision volumes. You can mirror body parts across, or you can go ahead and save out a setup and reload it back in, which is what we'll do in this example. So we'll go ahead and we'll bring in the dude 2, which basically just has those volumes positioned properly for this character. So now what we're going to do is go ahead and look at what the ragdoll solve looks like. We'll bring our solver active and we'll bring it online. I had that piece of geometry or that collision object highlighted, so that means I'm going to basically have it pinned, and we don't need to display that guy. We'll just start grabbing our character and sort of quickly moving him around, and you get a sense of how that ragdoll feels. If I deselect the object, obviously it drops to the ground, and the physics engine handles the fall for us. Now what we want to do is we want to have the animation that we worked on previously bring our character along for maybe the first 25-30 frames, and then have the physics engine take over, and we want to have a certain area of the animation trip. So this is pretty straightforward to do inside of MotionBuilder. What we'll do is we'll switch the activation of that ragdoll from an active mode to a passive mode, and that now means that the animation is going to be driven by the overall keyframes that we have on our control rig. So here you can see our character is basically running forward, and there's no dynamic simulation happening at all. We're going to go and animate the active-passive state of this dynamic simulation. At frame 24, it's going to be a passive mode, so we'll go ahead and we'll keyframe that. We'll jump forward one frame to frame 25, and we'll just bring this to an active mode. Now notice that my live solver is set to a live state, so as soon as I put this to active, the physics engine kicks on and the guy basically drops to the ground. So if we rewind this one more time, let's go ahead and take the live mode off, rewind it. We'll set this as our start frame, so that every time I select the reset to start, that's the frame it's going to go back to, or the dynamic simulation is going to go back to that pose. We'll bring it back online, and we'll just play this back. So you can see now at frame 25, basically my character comes forward, drops to the ground, and does his trip. Now this is pretty good, but often you're going to want to modify the effect of the dynamic simulation, and MotionBuilder has a pretty substantial set of tools for dealing with this. We can use our pose-based system to add influences to the overall dynamic simulation. So let's go ahead and look at that. We'll bring everything offline. We'll reset this back to the start. We'll bring everything offline, and we'll go over to our pose window, and I've got a couple poses already in here. So I've got this pose for trip, which is kind of like this, and then I have a pose for the land, which is the guy sort of flattened out here. And we're going to make one more pose of the guy throwing his arms up at the beginning of his fall. So let's sort of go to maybe frame 25 or frame 30. Let's grab this handle for this character. We'll bring his arm forward, maybe bring it out a little bit, something like that. Raise that arm up, and we'll just continue to bring it forward a little bit more. We can do the same thing for this. Bring his arm forward a little bit. Raise that arm up so he's throwing his arms up in the air. Maybe we'll just grab his overall waist and give him a little bit of rotate. So he's going to kind of do something like that. And we're going to add this in as a pose. So we'll go over to our pose window. We'll create a new pose from this pose that we've just dialed in. So we've got this new one. And we can call this something meaningful like start. So now we have a bunch of poses in our environment, and we can use those to modify the ragdoll. So I'm still in my ragdoll tab here. We'll jump over to the animation, and we'll go to our list, and we'll say we want to use the start, and we want to use the landing. I'm only going to do it with 2 of them. So we have different types of poses inside of MotionBuilder. When it comes to doing dynamic simulations, we can do guides, which is what it would be set up right now, or we can do actual matching. Actual matching means it will match that position, and the match object in this example is going to be hips. So we'll go ahead and we'll have the start off at frame 25. We'll have it end at frame 30, and we'll leave the strength at a value of 1, which means it's going to be really rigid. It's going to match that pose in a kind of rigid way, and it won't have any softness to it or smoothness to it. We'll go ahead and we'll put our interpolation to fast, and our landing pose will also start at frame 25, but we'll just have this be a guide with a very low value, and it's going to bleed on or stop at a frame 163. So it's not really going to do a good job of matching that landing pose, and that's okay for now, because really what we want to look at is the start pose that we just dialed in there. So let's bring everything back online, reset to start, hit playback. Here comes my thing, and you can see now his arms are basically getting thrown up, and they're getting thrown up pretty quickly because that start pose has a very high value. If I drop this down to a value of maybe 0.8, rewind that back, play it back again, you can see the arms don't throw up quite as fast now because we dropped down that start value. So let's go ahead and go to the land pose now, and instead of doing a guide for this, I also want to have that land pose be a match pose, so it's guaranteed to get to that end position at some point. If I have my strength value set to 1, we're going to go ahead and turn that on. You can see that it's basically, as soon as I turned on match, what did it do? It went and it tried to match the effect of that land pose because it has a value of 1, and its range is happening over 25 to frame 163, and I'm at frame, 140 or something like that. So it's done a job of matching that because we're in the live mode. So let's go ahead and play this back one more time. And here comes our guy. He throws his arms up, and then that match pose bleeds on, and my character kind of just lands there at the end. And he matches it 100% because my end strength value is set to 1. So we'll just drop that down to something like a value of maybe 0.9. So it'll have a little bit of softness to it. It won't be quite as rigid. The guy kind of dies, and then he sort of flops himself over there. And we can play around with how fast this happens, how slow it happens. So now it'll happen a little bit quicker. By frame 130, he'll reach that pose instead of frame 163. So he's going to whip over a little bit faster now. And we could maybe drop down that strength of that to something like 0.7. So it's a little softer, a little less rigid as far as the overall match happens. So that is how we can use dynamic simulation inside of MotionBuilder to animate a trip using pose-based animation on top of that to influence the overall effect of it. So we saw lots of things in this presentation. We started off looking at how we can generate some shaders. We then used some tools to retarget some existing animation and saw how we set characters up inside of MotionBuilder. We then used the story tool to animate multiple animation clips together and edit them non-linearly. We modified that animation using animation layers to increase the effect of that backflip. And then we just simply finished off by showing you the dynamics engine and how we can use that in conjunction with the pose system to modify the overall effect of a dynamically driven ragdoll.